Greetings. This is a flash talk covering the topic of the ATLAS Tile Calorimeter's performance and its upgrade towards the High-Luminosity LHC. The ATLAS Tile Calorimeter, also known as Tile Cal, is a sampling calorimeter which forms the central region of the hadronic calorimeter of ATLAS. Tile Cal is responsible for the measurement of jet and missing energy, jet substructure, and triggering, including muon information. Tile Cal is modular in nature and consists of 256 wedge-shaped modules arranged azimuthally around the beam axis. An individual module consists of alternating steel tiles and plastic scintillating tiles, as well as a super drawer which houses the front-end electronics as well as photomultiply tubes. Particles produce light when passing through the active tiles. This light is then transmitted to the photomultiply tubes via wavelength shifting fibers. The HL-LHC Tile Cal front end consists of the following elements. We will be concentrating on the low voltage power supply, or LVPS, which provides power to the front end electronics, while also monitoring critical values as its operating temperature and output voltages. The start of the operation of the HL-LHC is planned for the year 2027. With a foreseen integrated luminosity of approximately 4,000 inverse femtobarns. Tile Cal must be upgraded so as to allow for a continued high performance in the new HL-LHC environment. A summary of the Tile Cal HL-LHC upgrades can be seen below. We shall be focusing in on the low voltage system, which is undergoing extensive upgrades. Focusing on the LV system upgrade, we can see that a third stage is introduced by the point of load regulators. These allow for the standardization of the LVPS bricks. A tri-state functionality has also been introduced, which allows for these bricks to be switched on and off individually, as opposed to in the legacy in which this was not the case. An extensive radiation campaign is also underway in order to validate the LV system components operation within the HL-LHC environment. On the right-hand side, we can observe some performance data taken during run 2. Referring to image 2, we know that the ratio of calorimeter energy at EM scale to the track momentum of single hadrons can be used to evaluate both uniformity and linearity during data taking. We can see good agreement between the data and the MC simulation, as can be observed over here. Now looking at the test beam performance, we know that 7 test beam campaigns were carried out between the years 2016 and 2018, which made use of prototype front-end electronics as well as power supply systems. The test beam shows good performance of the new front-end electronics, as can be seen on the right. The fractional resolution in data and MC for protons, kaons, and pions was obtained with a slight improvement in resolution being observed. The detector response has been studied, determining the ratio between the energy deposited in the calorimeter cell and the track path length in the cell. The data shows the layer uniformity at around 1%, which is great, and an offset of max 4%. Thank you very much.